Okay, so good evening, students. This is Dr. Dong. Today we're going to learn the topic about thread. So last week we just finished the topic of process, and in process we learn several things, which includes the process memory space, and we say that the memory space of a process is like the area of the process that a process occupies in the main memory. So for each process, its memory space includes four parts: text, which stores the program in the binary format, and then we have data, which stores the static and global data, and heap is for local dynamic data, and stack is for local static data. So then we learn a very important diagram which shows that how can the process transit between different states, which includes the start, new running and ready and wait, and also terminate. And also we learn the process control block. You can take the process control block as a snapshot of the current state of a process or the current stage of the process. So and then we learn some process operation techniques. So and these are more like programming. So we learn that for us to create a new process, we can use the fork system call. And so fork, basically, if we call fork to help us to create a new process which has almost exactly the same thing with the parent process, but fork will just return 0 in the child process, will return a positive value in the parent process. And then we can use the system called wait to let the parent process wait for the child process, and so that it only resumes its execution after the child process finishes. And then we learn two different ways to terminate a process. The first one is the kill command. So if we execute kill followed by the ID of a process, we will kill that process. Or we can use the exit system call in our program when we are programming. Okay, so today we're going to learn a topic which is very similar to process, and I think most of you should have heard about this term, but I guess for most of you this concept you probably heard about this concept, but this concept is not quite clear for you. Okay, so the topic that we're going to talk about is thread. Today we're going to talk about the motivation for people to create threads, and then the benefit, and also a relatively important topic is named multi-programming. And then after that we're going to again learn something about programming. So it's the the programming with the POSIX Pthread library. So this is Pthread library is like a library that which enables you to create and manipulate multiple threads in the Unix-like system. And this library is widely used in the industry. So, but it's quite hard to learn it. So I'll just let you have a taste of that. And but the reason why I don't enforce you to have any real programming experience with it is because only very limited number of our students are going to use this library in their career. So you probably will only use this library if you are doing like, for example, if you are developing a game, it's actually not a game, it's a game engine, or you are going to develop something which is very close to say the operating systems. So I taught this course, I think, for 2 semesters. In those 2 semesters, around 100 students were in my class. Out of these 100 students, only one of them who having a job while doing his master study is using this library in his work. Okay, so that's why I just said, as I told you before, I just want you for this course. I really don't want to give you a lot of coursework, but instead I just want you to have knowledge, to know there exists this and that, and to know there it exists a library called Pthread, and which allows you to manipulate threads by using programs. So before I start, I must have to apologize for preparing this video lecture late. So last week, not last week, this semester, I advised the master project for 2 students, and one of them is doing malware analysis. So last week I was exploring a couple of malwares together with these students. Basically, we want to collect the network traces of these malwares, and so that we can build a profile for them, and in the future we can use this profile to detect the malware. So that is the main idea. But unfortunately, last week we tested maybe like six malwares, and one of them just crashed my laptop and the student's laptop. So my laptop was literally dead from last Thursday. Okay, so I can open it, but it will just not do anything for me. Okay, so it took me 3 days to get everything recovered, and now I just get back to normal and come back to record this video for you. Okay, so it's my bad that I should have tested that malware in a sandbox, but I forgot to do so. So which causes the delay over here. That's my fault. I guarantee that this will not happen in the future. So here, let's look at the reason why people design thread besides process. So again, let me log on to my server. So okay, so over here I'm just going to use light color to make it clear for you. Okay. So, okay, so I just create open a terminal. Okay, so here I'm going to log on to one of my servers. So before that, I need to make sure that I connected to the I connect to the campus network with VPN. So wait a second, I need to type in the password, temporary password over here. So okay, now I got the campus network. So SSH at say core 009 dot system dot clear AD. Okay, so here I'm on my one of my servers. Okay, I'm not sure if you still remember this command lscpu, which basically lists the detailed CPU information over here. So over here you can see that I have 8 CPUs, and each CPU. Here, threads per core. So for every core in my CPU can run two threads at the same time, and so the number of cores on average, there are four cores on each socket. So here this is the reason why people design design the concept of thread. Okay, so let's come back to the slides. Previously, we said that we learned that process is the unit to occupy a CPU, so so CPU is the central processing unit. So at a single time, a CPU can only execute a single process, and this is the memory space for for the memory space for process. We have the code area, data, files, and we have the registers and the stack. Okay, so this is the process memory space, and just right over here, this okay, this is the process memory space. So like if we only so most processes or most process only have one thread. You can take thread as the unit to take a core, to occupy a core. So which means that okay, even though we have multiple cores, yes, we only have a single CPU, but that single CPU may if you use i5 CPU, it has 4 cores, 4 to 8 cores. If you have a i7 CPU, then it has 7 cores. Sorry, it has 8 cores. The problem is that okay, so each core can run a command each core is able to run a command at a single time. So, but for most processes, it only leverages one core of your CPU, and which causes the waste of the other 7 cores or 3 cores. So then people just say, okay, I'm not going to waste those cores. Instead, I'm going to do this. Okay, so I'm here. We can say that here we can say that they just create here in this area. In this area, it just creates the multiple threads. So each thread can occupy a core. So which means that we have 3 threads or 3 different commands running at the same time. And this is the purpose of proposing threads. So threads, you can take thread as a lightweight process. Thread is actually you can take it as the unit for program execution. Okay, thread is inside a process. So it shares multiple threads share the same memory space. So they share the same code, the data, and also files, but they have their own registers and a stack. So if you remember, stack stores the local static data. So they can have their own version of data, but they just run the same code. Okay, they run the same code. So here we basically have 3 different copies of the code running at the same time. So think about where are we going to utilize this design in most cases. So suppose here you have a server or you are running a game server. So I'm not sure what is the most popular game. Like the last game that I played was Dota 2. It was like 4 or 5 years ago. Yes, 4 or 5 years ago. So for Dota 2, it's like we have multiple users and which connect to the same server. So like 10 users are connect to the same server and they play in the same game. They compete. So 5 players in a team, the other 5 players in a team, they just compete each other. So here they basically these 10 players or just connect to a single remote server, and that remote server is going to run the same version of game for this 10 different users. So this is the place where multi-threading multi-threading is going to help a lot, because with multi-threading, on that remote server we can just run a single version of the game, but we run a copy for each user, and this is going to be like 10 times more efficient than just having a single thread process. So this is the main motivation to have a to have multi-threading. Okay, so so and also you can take the example as a web browser. So when we are using web browsers, so we can run one thread, which helps us to display the images or text, while the other thread is responsible for receiving data from the network. So you keep refreshing your current web page. And so people may say that why not just use multiple processes? So why not just so yes, it's possible for yes, we can create multiple processes, but the thing is that if we have the with if you create multiple processes, you will have the same, you have to duplicate the code, data, and files multiple times, and this causes a waste of your memory space. And another major reason is that, okay, so like if you want, so if you have process A and process B, and if you only have a single CPU, they cannot run at the same time. So you have to let your CPU switch between these different processes, and this process switch also takes time. So it's not going to be as efficient as having multi-thread. Okay, so this is another very famous application of multi-threading. So which is a web server. Okay, so if you are running a web server, you are going to handle the request, the HTTP request from multiple users, and each time when a user sends a connection request, the web server is just going to create a new thread to handle that request, and then so in this way, so a single web server can handle the requests from multiple users at the same time. So this saves the computational resource and also improves the user experience. And so actually nowadays we have more and more programs programs that are leveraging multi-threading. So, but unfortunately, most of them are either games, or like browsers, or like the system processes. So if you look at a snapshot over here, you can see that so we have a lot of processes with multiple threads running. So some of them are like iExplorer. iExplorer is like the Internet Explorer. Okay, so it's the web browser, and most of the other ones are just system processes, or just so. And also a big family of multi-threading programs are just games. So so if you are interested in game engine development, you should definitely go for this direction. But it's really hard. So when I was doing my PhD, my university, and actually my previous department, offers a course called multi-threading in CUDA. In CUDA, I don't remember the exact name of that course, but the idea is that they're not going to create multiple processes on the CPU. Instead, they're going to create multiple threads over the GPU. That is why the CUDA comes. CUDA is like the driver for NVIDIA GPUs. I think I tried that course. I registered that course in one semester. I say, okay, this course sounds really cool, and I remember that I was really excited to register that. But what I saw is that, so in the beginning, that course is really full. So in the first week, it's like there are more than 40 or 50 students, even though the course cap is only 30. But what I remember is that only after 2 weeks, there are only 6 students in the classroom. Okay, yes, so in 2x, so the level of programming difficulty just make a lot of students choose to go for the other courses. So that is really hard. But if some of you just has an interest of going into that direction, I'm going to be really proud of you. But anyway, I'm not a good programmer for CUDA programming. Even though nowadays I'm using GPUs for deep learning, but I'm just directly, it's like I'm directly using some libraries provided by Google. It's called TensorFlow. I'm not going to handle these low level things. So so here this is the the diagram showing that showing the advantage of multi-threading when there are multiple cores in our system. If we only have a single core, multi-threading is not going to help us much. But if we have more than one core, then we can definitely say that we can have multiple threads running at the same time, and this is going to improve the efficiency, the programming efficiency a lot. So okay, and so far I think we have learned a lot, several concepts. The first concept, which are really confusing. So the first one is multi-programming. So multi-programming is like we have more than one programs loaded in in memory for execution. Okay, so this is multi-programming, and then the other concept, which we just learned today, is called multi-threading. It's like we have a process contains multiple threads. While multi-core programming is like we run multiple threads in parallel across multiple cores. So the multi-threading and multi-core programming are strongly correlated. So if you go for multi-core program, definitely you are going to go multi-threading. So so here just for the purpose of this course, you only need to understand the difference between multi-programming and multi-threading. Okay, so here next I'm going to talk a little bit about the programming part for multi-programming. So for multi-threading. So here previously we said that we have two different levels of library. The first one is the kernel library. So it's like these are most of them are like the system are just system calls. So it's like so they're just the program interface provided by our operating system kernel. And then there are another type of library. We call them user library. For example, C++ or Java. They all provide a lot of libraries, and these are just user libraries. Here, if we want to do a little bit of programming with thread, okay, like create multiple threads, then we have to rely on some libraries. So the most famous choice of library for multi-threading is called POSIX thread, and we just call it Pthread. So this library can operate in both user and kernel mode. So this is the most popular choice, but it mainly works on Unix-like systems. While if you are using a Windows system, if you want to do multi-threading on Windows system, then you need to do Win32, the Win32 library. Now I think it's Win64. And here you can say that, okay, this is a very interesting thing. So previously, like let's say maybe more than 10 years ago, there was a very famous game. Let me show you what it is. It is called Warcraft 3. Yes, I think this is called, yes, the Frozen. Yes, yes. This is the game. So this game was released by the Blizzard. Yes, Blizzard Entertainment Company. So this, when I was in my high school, this game was like the top one game, and so it's so popular. So and I remember that I even played this game when I was in my college. So in my college, some of my students choose to use some of my classmates choose to use like they want to use Linux systems, operating system. But one big concern is that so this company, the Blizzard company, only releases the game, this game, on Windows platform, but there is no Linux version. So so at that time we were wondering why this company just do not release a Windows a Linux version. So it's just like using the same program compiled on a different operating system. So like over here you can know the difference. Okay, so because that game in that company only developed this originally only developed this the game for Windows system, and it is based on Win32, the Win32 library. Okay, so if they want to develop a different version for, or if they want to develop the game for Linux systems, they have to rely on the Pthread library. Okay, so which means that they have to change their program completely. It's like they restart the project, and this will cost cost a lot of funding for that company. So they didn't do that. So and this explains why for most games there cannot be so people have to develop one version for Windows system and another version for Linux system, because the libraries they rely on are totally different. And then here, so there is another choice called which is Java. Java also provides the Thread library. It's easier for users, or it's easier to use, but the problem is that it's not that efficient. So in the industry, if we have to go for multi-threading, most people will just go with POSIX, Pthread library or Win32, and Pthread is more popular than Win32. So, and this is the reason why we're going to, in our course, we also are going to focus on it. So Pthread library is like a so if you Google it, Pthread library, so you will be able to find. Let me see which page. Yes, this is the page. So you will be able to find a very good web page which discusses what it is, and also it tells you what is a thread. Okay, so this web page is really great. So I learned multi-threading. Most of my multi-threading skills from this web page. So here, then let's come back to the slide. So today we're going to talk about two different functions, or two different parts of this library. So we're going to talk about in our course we're going to learn two different parts about this library. The first part is thread management, like how to create and terminate a process, how to join and detach a process, and this is our main topic today. And let me say, probably in 2 weeks we're going to learn another concept called thread synchronization. So it's like we need to synchronize or coordinate different threads to let them run in a certain order so that there is no error. So, and that is called thread synchronization. And so it will be our topic in 2 weeks. Okay, so this is the library. So it's a standard Rest C language library. Okay, so here if we talk about C, I think most of you are just going to knock your head because this it's not easy to program in C, and I absolutely know that, understand it. So I'm not going to require you to have the skills to use this library, but instead I just want to show you how to use that library, so that in the future, if you in your work you by some so you if you need you are required to use that library, you at least you have an idea. Okay, so first, so this library is available for Unix-like systems. I think for most of you, if you are using a Unix-like system, it should be either say Mac or Ubuntu. So I think for this library comes naturally with a Mac machine, so you will have it. But for if you use Linux, if you use Ubuntu, and this is the command, you just need to copy and paste this command, and then to your terminal, so that you will be able to install this library. And after you install it, you can check if you have it or not by using this. Okay, so by using the first command, ldconfig. So if you see an output like this, if you just see any output, then it means that you have it with your on your machine. Okay, so but if you don't, if you don't, just copy and paste this command so that you can install it. And here let's look at some functions provided by this library. The first one is called Pthread create. So this is like with this function where we can create a new process, and then we have exit. It's like we terminate a process and let it release the resource it takes, which includes the memory space, also the files that it opens, etc., etc. And also start routine. This part is called so this part we have the start routine. Start routine is basically a function. So it's like when you create a thread, which function do you want this thread to execute? And arg is for arguments. So what kind of arguments do you want to pass into that function? Okay. So so for the other functions, for the other three functions, we don't need to worry about them. So first, let's look at what does the pthread create function do for us. That's main pthread create. So in the manual, you will be able to find, okay, the pthread create function starts a new process in the calling starts a new thread in the calling process, and the new thread starts execution by invoking the start routine function, and so arg, which is the argument, is passed as the sole argument for that function. So okay, so here next we're going to say how we are going to create that so create a new thread with the help of the pthread library. So I provide the pseudocode for the code for you already. So let's go documents teaching. Okay, so yes, this is the thread creation. Let's look at the first code. So this is the code in which we are going to use the pthread library to create a very simple thread. So here in the first line we have the include header. So it's like we include pthread.h. So this if you are familiar with Java programming, So this is pretty much like the import java.util.star. So it's like we're going to use the functions provided in this header file. Okay, and then so let's look at the main function. In the main function, we first declare a new thread, so whose type is pthread t, and so then next we have this pthread create a new thread, so with null. Let's look at what does the, so if we go back here, so the second parameter is the attribute, is the attribute of the process that we want to pass in. So if you pass in null, it will just now it means that the new process will have the default parameters or default attributes. Sorry, default attributes, not parameters. And then the third, if you remember, the third parameter is the most important one. It's the start routine. So it's like which function do you want this thread to execute. So here we have we pass in the function print hello, and we have the definition of the print hello over here. So in the print hello one, what we do is that we just get the thread ID. We're just going to get the thread ID, and then and then print that out, print out a message saying that hello world, it is me, thread, a certain number. Okay, thread followed by the thread number. And so the last one that we are going to pass in is just the thread ID. So the last parameter that we pass in is just the thread ID, and here we give the ID 0. And so if RC so if this function returns a value larger than 1, then we're just going to say print out an error message saying that return code from the pthread create is what. So here, if we look at the menu, let's just go to the return value of this function, of this pthread create function. On success, this function returns 0. On error, it returns an error number. So that's the reason why we have so in the function we have this. If RC is not 0, we are just going to print out an error message. It means that we failed to create a new thread. And last, we just terminate in the main thread. Okay, so here let's see how we are going to compile this file. Okay, so we have GCC. We followed by the source file, and -o. So if you remember, -o means it's just telling that what kind of like output do you want to have. So here we are going to say, let's give the name try, because currently this from the ls command you can see that the current folder does not have a file named try. And then remember that we need to have the -l option with pthread. So with this -l is like you want to link. -l pthread basically tells the C program compiler saying that I want to link this program with the pthread library. Okay, so with that, we will be able to compile the programs successfully. And here you can see that we got a new file, and so its name is try, and let's just run it. So here you can see that in the output we say in main we are just creating thread 0, and so in the thread it just executes the print hello function with the message hello world is me, thread number 0. Okay, so yes, this is what this function does. Okay, so first in the main function we print out, so in main creating thread 0, And then in a thread, so after we create this thread, it will just go to execute the print hello function, and in which it prints out the sentence hello world is me thread number 0. So this is exactly the same as what we say over here when we execute the program. So let's just remove try. Okay, so this is the how to create a new process. So here some of you may say, okay, what if here we want the main function to do something else after this thread is after the new thread is created. So actually it's not a very good idea. So here I'm not going to talk about the detailed programming part over here because it's too early. So I'm going to put it off at the time when we want to learn the process synchronization part. So the general idea is that your main function is, so the best practice is that your main thread or your main function is only responsible for creating threads or terminating threads. So and do nothing. So it's like your this is like your main function is like the master of all the threads that you create, and this is a good way to keep your code clean and neat, and it's easier for you to debug your code. Okay, so so this is the how can we create a new process, and based by using the Pthread library. Okay, so in summary for the programming part, so we know that so in case of multi-threading, the main function should only be responsible for manipulating threads, and to compile to use the Pthread library. So in the first line of your program, you should have the include pthread.h to declare that you want to use this library. And also, when you compile the program, you should link it with the Pthread library. Okay, so so this is the our topic today. So compare with process, thread is not that important, but it's good to know that this so thread is basically a lightweight process, and it is so by having multiple threads we can leverage the multiple cores in a single CPU and let multiple threads run at the same time, and so this can boost our program or process efficiency. Okay, so this is the lecture for today. Thank you for your attention, and so I will talk to you next week. And also here, so I think at this time we are just 1 week from a half of the semester, so it's like we spent 5 weeks together already. So a little bit more than 1 month, and I don't know, how do you like this course so far? Like, are you bored with this course, or say are you just satisfied with this course because there is no homework yet? And by the way, our first homework is going to be released the next week, and but take it easy. It won't. So I suppose that I think that for most of you, it will only take you 2 hours or 3 hours max. So don't worry. As I promised, as I stated in the beginning of the semester, the point of this course is to give you some knowledge about the design of operating systems. So these are not skills. Skills are something that you will need in order to find a job. Okay, solid skills are something that you will need in order to find a good job. But this one is knowledge. Knowledge is something that you need to know. So, and it will help you to broaden your horizon. So this is the reason why I don't want to take a lot of time So take a lot of time from you for this course. So you'd better spend your time on the courses that help you to build those solid skills, especially programming part. Okay, so so but I do want to know your opinion on this course and your honest opinion. I don't want you to say, "Hey, professor, I like everything about this course," but like maybe the only reason for you to say that is that you don't want to offend me. So here I think if you did your education in the if you have a couple of years of education experience in the United States, you probably know a very famous website, which is the Yelp for professors. Like, and that very famous website is just called readmyprofessor.com. And so here you can give reading to the professor, to any professor actually. And so over here you can just Google, and so you can just copy and paste my name. Unfortunately, there is only a single person. Um, so on this website there is only one single person with my name. That's me. Okay, so you can just go there and so submit your reviews. Okay, so I want your honest review. To, so you better tell me what you like and what you don't like with this course so far, so that in the second half of the semester I can adjust this course to make it work for you the best. Okay, so guys, I will be refreshing that web. I'll be visiting that website sometime next week to see your feedbacks. So the good thing about that website is that it provides a way for you to submit your reviews anonymously. So I'm not going to say who reviewed me and what kind of comment is left by which student. So don't worry about that. Just your honest reviews. Okay. So thank you, and I will talk to you next week.